11s, I want us to look at the topic, the nature of roots. The nature of roots. Nature of roots. It is very important that you understand the concept. The nature of roots of an equation. Remember, it deals only with quadratic equations or quadratic functions, whereby they are expressed in the form of ax squared plus bx plus c. So your equation should be in this format. And then remember, when you solve for x, you always get get two x values. Maybe x is equals to 4 or x is equals to -1. You always get two x values. So nature of roots, we describe those x-intercepts, those x values, whether they are, we describe them whether they are real or non-real. That's number one, real or non-real. When they are real, remember, real numbers might be rational or irrational. From the number system, remember, real numbers include, when you talk of real numbers, it includes rational and irrational. And then under rational, we have integers. You might get integers, you might get whole numbers, you might get the natural numbers. So example, x is equals to 4, x is equals to -1. They are real because of they fall under integers. -1 is an integer, also 4 is an integer. So they are rational and also they are real, remember. And then if you get maybe x is equals to 2 plus square root of 5, or x is equals to -2 plus square root of 5. Because of the square root of 5, it's a third. It means that it's a third. It means thirds lie under irrational numbers. So the roots are irrational, but also remember they are real when you use this number system. So that's what we check. But immediately you get the square root of a negative number, example, it means it's non-real. That's the only special case. Very, very important. So that's what we are checking. We are also checking whether the roots are rational. I just mentioned now, rational or irrational. That's the important aspect. And then we also check whether they are equal. Two equal solutions, meaning that equal, we have example, x is equals to 2 or x is equals to 2. Those are equal roots. When you solve, then you get such x values, then we've got equal roots. Then unequal, when we have example, this case over here, these are two unequal roots, meaning that different solutions. You've got different solutions. That is the number one aspect. So it's very important to note that. Again, when we, I'm sorry about this, when we look into nature of roots, I hope you remember the formula x is equals to -b plus minus the square root of b squared minus 4ac all over 2a. We are mainly checking this expression which is within the square root, which is within the root. That's why they say nature of roots. So we are looking at b squared minus 4ac, and we call that delta. Delta is equals to b squared minus 4ac. That's very important to note. It's the value of the expression of b squared minus 4ac, known as delta. So that's very important. So let's look at a basic example. A basic example on how to discuss the nature of roots. So let's say you have a quadratic equation, x squared plus 3x plus 4. It's a quadratic equation. Guys, you have to identify what your coefficients. You have to identify your constant numbers. Example, A is equals to 1 in this case. There's a 1 there. And then B is equals to 3. And then C is equals to 4. Then you use a formula for nature of roots. You use delta. Then you say delta is equals to B squared minus 4AC. Then what is your B value? The B value is 3 squared minus 4. What is your A value? Your A value is 1. Your C value is 4. Then you say 3 squared is 9 minus 16. 4 times 1 times 4 is 16, which is negative 7. You found delta. But now you have to know something. You have to know how do you describe, how do you discuss the nature of roots. Now the important thing, you need to learn this table that I'm going to give you. I'll go back to that example later on. You have to look at this. You have delta here, remember. Under delta you can say delta less than 0 and also delta bigger than 0. So when delta is less than 0, meaning that when your delta is negative, when you get a negative answer after calculating your delta, it means that the roots are non-real. Why is it so? Why? Remember, your delta is within a square root. Your delta is within a square root, B squared minus 4AC. That is your delta within the square root. Now, your delta in this case is negative 7. So when you get negative 7, then the roots will be non-real. I hope it makes sense. Because of a negative square root. So for non-real, delta must be less than 0. Then delta must be greater or equals to 0 for real. As long as, for example, if we said negative numbers, it's non-real. But now when you get 0, square root of 0 is 0. And 0 falls under whole numbers, natural numbers. So it means it is real. When it's 1, it's also, the square root of 0, let me just confirm that, sorry. Yeah, it's 0. Square root of 1 is 1. It's still real. Square root of 2 is square root of 2. It's still real, but irrational. But they are still real. That's why they say delta bigger or equals to 0. That's where we have real roots. Good? But now under real roots, it will branch into 2. It will branch into 2. We mentioned unequal roots. We also mentioned equal roots. Now, unequal is when your delta is only bigger than 0. Like, it doesn't matter when your delta is bigger than 0, meaning that you will get two different solutions. You might get two different solutions. Either they will be irrational or they will be rational, but you will get two different solutions. And then when your delta is equals to 0, that's when you will get when your delta is equals to 0, that's when you will get equal roots. I will just find that example somewhere where you get equal roots when your delta is 0. Then it will lastly branch under unequal, where we look at when delta is perfect. Perfect means we look at perfect. The square root there is perfect, meaning that you have square root of 36, which is 6, square root of 144, square root of 121. Remember these. Why am I writing 11, 12, 6? So these numbers 1, 4, 9, 16, 25, and so on, those are known as perfect squares. So when delta is perfect, the roots are rational. You must know that the roots are rational. When delta is not perfect, then the roots will be irrational. So let's go back to that example of ours. Example 1, you got negative 7 as your delta. Therefore, what is your conclusion? There's only one conclusion that you can make. you can say here the roots are non-real. That's your answer. Then when we let's look at example number 2. Example number 2. Let's say you have x squared minus 5x minus 6 is equal to 0. Let's identify our variables. A is equal to 1. Our coefficients or constants. A is equal to 1, B is equal to -5, and your C is equal to -6. Meaning that your delta, let's find delta. Delta is equal to b squared minus 4ac. What is your b value? Your b is -5 squared minus 4. Your a is 1. Your c is -6. Then you punch this in your calculator. Now we just do it manually. So it's 25 plus 24. Then what is 25 minus 24 is 49. What do you notice about 49? 49 is a perfect square. It's perfect. It's a perfect square. Thus, it's obvious that it will be rational. Then you just go up. It will be because it is not equal to 0. It's not equal to 0. That 49 is not 0. It's 49. It means they are unequal. It's bigger than 0. Then obviously it's real. So because of that perfect thing, therefore the roots here, roots are rational. They are unequal and they are real. Can we solve that so that we can see what do they mean when they say they are equal? They are unequal, they are rational and real. When you solve that thingy, x squared minus 5x, the equation, when you solve it, you can use a quadratic formula. It's x is equal to minus b plus minus the square root of b squared minus 4ac all over 2a, which is x is equal to minus 5 plus minus the square root of minus 5 squared minus 4 into 1 into -6 all over 2 into 1. Then when you simplify the square root, it will be x is equal to 5 plus the square root of 49 over 2 plus minus. Then when you get your x values, your x will be 6 or your x will be -1. Let's look at these x intercepts, at the x values. What do we notice? Firstly, they are integers. It means they are rational. And then these are two different solutions. They are very, very unequal. And obviously they are real because there's no negative number there. They are real. I hope it makes sense. This is just for understanding of why do we say they are unequal. Let's look at another example. Let's say you have x squared minus 6x plus 9 is equals to 0. Then let's find our delta. Delta is equals to b squared minus 4ac. Then your a is 1, your b is -6, your c is 9. Then you're going to say b is -6 squared minus 4 into 1 into 9. Then when you punch in your calculator, you are going to get a 0. What do we know when you get a 0? When your delta is 0. Guys, you must memorize this table. It's very important. When you get delta is equal to 0, the roots, obviously, they are equal. It means it branches from here. Check. It branches from a perfect. Oh, it's not perfect. 0, you don't mention perfect. It means you're not going to talk about what is this? Oh, okay. Let's check only the word perfect. Equal for now. I'm sorry. So it means the roots here will be equal. And when roots are equal, it's obvious that they are rational. No. Yeah, it's obvious that they are rational when you have equal roots. I'll just make sure of that. So in this case, the roots are rational, they are equal, and also real. That's how you make a conclusion. So to test that we are correct, you don't have to test, but now this is for understanding. Why do we say they are equal? When you solve using quadratic, also minus b plus minus the square root of what? B squared minus 4ac all over 2a. It will be minus, what is your b? Is negative 6 plus minus the square root of negative 6 squared minus 4 into 1 into 9 all over 2 into 1. When you simplify, it's going to be 6 plus minus the square. Remember, we got a 0 for the whole square root is 0 all over 2. Then when you punch in your calculator, you're going to get the same answer, x is equals to 3 or x is equals to 3. Now it means very the roots are equal because of the two intercepts. They are the same. So that will be all for now. I think I made an explanation on how you discuss the nature of roots. The next video will be about solving the value of finding the value of k, value of m, for which the specific equation has equal roots, for which the specific equation has unequal roots or non-real roots, just like that. As long as you have gained this piece of knowledge, it is very imperative for you to use it in our next video. Thank you so much.